Hello, this is Python programming for A-level computing, and in this webcast we're going to be looking at variables and how to assign values into variables. I'm Matt Scott, and this webcast is delivered by the computing department at Oldham School. So a variable is essentially a place in the main memory of the computer that can store one or more data values. You'll be familiar with variables from your study of mathematics, where you might have variables like x and y, or maybe if you play computer games, things like score and other kind of things that have a numeric value attached to them are generally a variable. A variable has an identifier, as in its name, in this case it's user selection, and also a value, and here it's pork, and we know that the data type of pork is text because it's been given the speech marks around it. Identifiers are the names that programmers give to things in their code, so it's not only variables that can have identifiers, also procedures and classes, so a range of structures that if a programmer creates it, then they'll need to name it. That name is an identifier, and when you choose an identifier, it must always start with a letter, in Python at least. It should only contain letters, numbers, or the underscore character, and it can't be a reserved word, which might be one of the following terms, or it could be inbuilt functions within Python, like things like print and input. These words have been reserved for other things, such during the running of the code. So, given that we had those three rules, it has to start with a letter, you can't have symbols in it, and it can't be a reserved word. Which of these do you think are valid and invalid? So, looking through, count, temp, and input value are all valid. Input value has a symbol in it, but it's the underscore, so that's okay. Global is invalid because it's a reserved word. The second value starts with a digit. The yes no has a forward slash, and the interpreter would interpret that as two variable names and you wanting to divide the one by the other. Input value is also false, not accepted because it's got a space in it, and input is the name of a built-in function, so that won't work. So there's a few ways that you can assign values. One is to pass them using what's called a tuple, whereby each of the values is passed into its respective variable. So A becomes 1, B is 2, and C is 3. Alternatively, you can cast one value into multiple variables. Here, both A and B have been appointed to the value 3. You'll note that in this instance, B does not become 4 here. What this instruction does is it tells the interpreter to write 4 on the screen, but doesn't actually assign the value 4 into B. That's what this statement here does. So here where it says B equals B plus 1, that would assign the value 4 into B. And you would expect probably this to be 3, 4. However, you might be thinking that this should be 4, 4 because you pointed A at B, and so A should follow B's value throughout the execution of the code, and this isn't true. Here we've just assigned the value 3 into B, not and so A remains with the value 3 until right at the end, so it will output 3, 4. Each variable in Python at a given point has a data type, and the type of data is basically dictates how the programming language will react to it and what operations can be performed on it. Here's some examples of different types of data. You've got an integer here, or a whole number, a string, or a bit of text. Here you've got a floating point value, or a decimal number as you might understand it. Lists in Python can have items of different data types, which is unlike other programming languages. And a tuple is like a list, but it's immutable in the sense that it can't be changed, and so you could not change the value of this item from 23 to 24. And this isn't a complete list of all the types of data in Python, and the complex value, so where j is the square root of -1, just sort of shows the sort of real range of different data types you get within the Python environment. And because Python decides what type of data the variable is storing when it gets the data assigned into it, we would call this a weakly typed language, and it contrasts to something like C++, which is a strongly typed language, and which we'll talk about on the next slide. So C++ is a strongly typed language, and this is because you have to declare the type of data before you assign the data type, before you assign any data into the variable, and then after this point the data type can never change. And so if you look at this example code of C++, this basically assigns 5 to A and 2 to B, and then adds 1 to A, making it 6, and then returns 6 minus 2, so it returns 4. So this would print 4 on the screen. You'll note first, however, that before they can actually assign the variables in this strongly typed language, they declare them and also declare what type of data they are. So we'd say this is a strongly typed programming language. So data type control how you can actually manipulate the data. So for example, in Python you can times a string by 2. So string value here would be hello hello after this operation has been called on it. But equally, you can't use the plus sign with a string, so you can't add 2 to hello. That wouldn't be that's not syntactically correct. And we're going to look next week. We're going to be looking into the different operations that you can do on different types of data. For the moment, we're going to look, however, on the arithmetic operators and the fact that you can actually assign the result of a operation, or in this case an arithmetic operation, into a variable. So here we've got the value x, and we assign into it the value 57, but the computer calculates the value 57 before it's assigned for us. It's important to note that assignment only works from right to left and not left to right. So here where I've said 1 plus 56 equals x won't work. You can actually even add a value to the number already stored in a variable. So here you've got x equals x plus 23. So that takes the value that's stored in x, adds it to 23, and then places it back in x. Mathematicians aren't really very comfortable with this because they would see the equal sign as denoting equivalence on both sides, saying x equals x plus 23, and that obviously can't be true. Whereas where computer scientists see the equal sign as meaning assignment, meaning taking the value on the right hand side and storing it in the place that's pointed to on the left. And this can be written in shorthand as x plus equals 23. That means add 23 to the variable x, and you can do this for all of the arithmetic operators. So you can do it for subtraction, multiplication, division, even exponent, which we'll look at in a bit, and floor division, and modulus function, which we'll also look at now. So if you're to look at this code, you can see that actually there's two ways of doing division. There's a floating point division, which will give you a floating point number, as in a decimal number, and there's floor division that will round down and take the whole number part of the division. The modulus sign, or the percentage sign, effectively divides the left hand side by the right hand side and then writes the remainder. So here 2 divided by 3 is 0 remainder 2, 2 divided by 6 is 0 remainder 2, 5 divided by 3 is 1 remainder 2, 15 divided by 3 is 5 remainder 0. So the percentage sign returns the remainder part of the division. It's also called modulus, and it's the whole number part and it's rounded down. You can also do powers in exactly the same way as you did multiplication. So a to the power 4 to the power 2 is 16, and you can actually place something as the power of itself. So here that would be a to the power 2, in the same way that we looked at plus equals and minus equals and divide equals earlier. So just like in ordinary mathematics, there's an order of operation of all these symbols that we've been through, meaning that the brackets are at the top and they'll be they'll be interpreted first, or their contents will be interpreted before other stuff. Exponent is after that. Then it looks at minus numbers. Then it looks at multiplication, division, floor division, and remainder on an equal footing, and then finally addition and subtraction come last. And so if you look, and when they come on an equal footing, like these two sections here, it will just implement it from left to right, so whichever sign is the closest to the left will be done first. And so this is exactly the same as your sort of BIDMAs in maths, brackets, indices, division, multiplication, addition, subtraction, and you'll be aware that 2 plus 4 divided by 2 is not equal to 2 plus 4 in brackets divided by 2. And so what have we covered today? We've looked at what's a variable, what does it mean. We said that a variable was a place in main memory where you stored data, and the data had a data type, a value, and the variable also had an identifier. We looked at valid identifiers and the fact that they need to have a start with a letter, and they can be a combination of letters and digits and the underscore character, and there's certain reserved words that they can't be. We've looked at how to assign values into variables using the equals command, and that you always have to assign from the right hand side to the left hand side. We've looked at another programming language. We've looked at C++ and said that was strongly typed because you had to declare the variables beforehand, whereas in Python the data type of the variables gets declared implicitly at the point of assigning the value, and this allows you to change the type of data in a variable at a given point. And we've also looked at how to assign the result of an arithmetic operation into a variable, and we've looked at the 5 arithmetic operators being plus, times, divide, both kinds of divide, and the modulus function. And we've also considered the order of operation, whereby brackets are the most important, then indices, then division and multiplication are on a, then division and multiplication are on a par, and then addition and subtraction after that. Finally, if we have a look at this question, can we see what are the errors with this, of which there are numerous? You might want to pause the video and then have a sort of consider how it could be improved. And so, rewriting this, to start with, we have an arithmetic operation on the left hand side and the variable on the right, so really you want to switch those two round. And so now we place number y on the left hand side, and we assign to the value number 2x plus 1. There's also a problem with the identifier names, which means they're invalid. Number y has a space in it, and so that space has been removed. It's also been camel cased, which means that you place the first word in lowercase and then the following words in uppercase. The n has been made into a lowercase because it's a convention to use variables with a lowercase. And number 2 has also been changed. You'll be aware that variables can't start with a number, they have to start with a letter. And once we've done that, you can consider what's the function of this. Well, the function of this is it will add the number the value of the variable number 2x and the value 1 to the value that's already stored in number y. So number y effectively equals number y plus number 2x plus 1. So thank you very much for listening to this short videocast. I hope you found it useful, and I look forward to hearing from your comments in the section below. Thank you.